I am Jan Lindblad from Cisco, the NSO group in the tail of team. Show you how we are using NetConf and NetConf network-wide transactions to manage a couple of devices. So we will show that we can manage IPI OcNOS devices. And in so doing, we will use standard open config models towards the device. And we will use IETF service models from the NSO service manager. And we'll show you how we have multiple service instances coming and going in this so that you can see that the orchestrator can really take care of multiple services that have overlapping needs. And with that, I'll hand over to Roberto from IP Infusion.
Hello, I am Roberto Romerding, test engineer from IP Infusion. And during this demo, I will show you from the device's perspective that L3VPN servers are fully functional after the configurations are pushed via NetConf from the controller using OpenConfig YANG models. During this demo, we will not have traffic passing through the VM device. So we will verify the functionality using VRF details, VPN v4 status, connected routes installation, and MPLS forwarding table. And after those checks, the services will be deleted according to the controller orders, and then we can check in the device that no services remain configured. This is the demo topology with Cisco NSO as a controller, which send NetConf RPCs to the IP Infusion OcNOS device using a management port. In the OcNOS devices, there is a network infrastructure already configured with VPN v4 BGP, LDP, and OSPF. After the receiving of NetConf configurations from the controller, there will be creation of VRFs, route distinguisher, and route targets in the device, configuration of the IP address of the client interface, redistribution of connected routes from the VRFs inside the BGP, and configuration of the MPLS labels for each L3VPN service.
Before we get to step one, we'll show that there's no configuration in NSO or on the device that has anything to do with this, so that you see we have a blank state. And then when we get into the actual demo steps here, I'll first create an L3VPN service using the IETF 8299 service model. And set that up in NSO and shoot a network-wide transaction to both OcNOS devices at the same time. And then the OcNOS devices will receive this configuration that NSO computed based on the service model and set up the IP interfaces, VRFs, RDs, route targets, and BGP VRF and routes and all of that. And once that is up, I will create more VPNs that are using the same devices. So that things are overlapping, then delete some of them so that you can see that you can add and delete routes or add and delete VPN services at will. And at the end, I will make sure that everything is back to clear and show you that there is no residual configuration left on the devices anymore. And as we create and remove configuration, we will show what the device configuration looks like and show that traffic could have flown. So with that, Roberto, maybe you want to show the device is blank at this point?
This is the running config from both devices. We don't have any VRFs both, except the management VRF, that is the full VRF. And we shouldn't have any VPN v4 prefix. So the devices are clean. Ian can start the configurations from the controller side.
Thank you, Roberto. And I'll show you what it looks like on the NSO side then. The first thing I will do here is to make sure that we are in sync with the devices. So in NSO, we say that device IPI 31 sync from, and we'll do the same with the IPI 32 device. So now NSO has a copy of the configuration on the devices and knows what to do when it comes to devices. We are in sync. And I'll show you that we don't have anything running on the L3VPN. There's just nothing under L3VPN service configuration. So let me create an L3VPN leg between Berlin and Frankfurt. I'll add Frankfurt here. And just to show you what's going on here, I'll show you the service configuration. So here I'm creating a site called Berlin, and it's attached to the IPI 31 device. And this whole VPN leg sits in the VPN called GER for Germany. And it has some IP addresses and MTUs and things like that. And then we have the other leg is called Frankfurt. It sits on the IPI 32 device, connected to the same VPN here. So that is the service level configuration according to the ITF L3VPN service model, or RFC 8299. And then NSO and the service application we have running in NSO will translate this into concrete device level configuration, allocate resources for it and all that. I'll show you what that looks like by using a commit dry run. This will show you exactly what NSO computed and will send to the devices. So we scroll a little bit backwards up and you see that based on that rather small service configuration, we will create a sub-interface for EAS2 on IPI 31. We'll set up some IPv4 addresses for that with the prefix. We'll create the new network instance called VERF3621. Set some descriptor for that, set router ID on it. We'll create an interface coupling, some tables for BGP, both IPv6 and IPv4. Set up BGP 100, some route targets, and the similar thing for IPI 32 with sub-interface 0, with some other IP addresses, same VERF, another router ID, and so on. And down here we have the actual service configuration that's being added in the same transaction. So if I'm happy with that, I'll just say commit, and here we go. So Roberto, maybe you can show what it looks like on the device side by now.
In the devices, we will have the configurations that Ian sent to us. I can show you the IP address of the interface that NSO sent to us. This is the IP address. Also, the other side. Also, we will have VRFs created. One VRF actually. It is the route distinguisher is also configured. Same here. And we should have VPN v4 prefix being accepted. This one coming from the other peer. Same thing here. We have this prefix. And we should have one route installed. This one coming from BGP through VPN v4. Right. So one service is working fine. Now we can go back to Ian.
Thank you, Roberto. Yeah, so let's create a few more services. I'll load up. Load the leg to Warsaw. And Katowice, and to Tampere, and to Helsinki. And I'll show you what those are about, so you'll see what I would commit. So here I'm adding a site to Helsinki, in Helsinki, that's connected to IPi31. And it's in a different VPN than is the Finnish VPN down here. And the site Katowice, which is sitting on IPi32, which belongs to the Polish VPN. And then we're adding a site Tampere, is also on IPi32. It's the Finnish network, and we have the site Warsaw, which belongs to the Polish network with some different IP addresses. So we'll create both of these VPNs with 4 legs at the same time. I'll show you just quickly what that looks like as in a dry run. What we send to the devices. As you can imagine, it's a little bit longer this time since we are creating 4 legs at the same time. So we are creating a sub-interface on E3 and E4 on IPi31, and setting up the VRF 1003 and the VRF 2039. And on IPi32, we are also creating sub-interfaces on E3 and E4 and connecting to the same VRF of 1003 and 2039. And here's the service config for the service level. I'll commit that. So over to you again, Roberto, so you can show all 3 running.
Now we should have 3 VPN services in the device. Exactly, we have 3 VRFs created. The same in the other peer. We should have 3 interfaces configured with IP addresses, ETH2, 3, and 4. Same thing here. We should have 3 prefixes coming from VPN v4. This, and this. Same thing here. 1, 2, 3. And we should have 3 prefixes coming from BGP. So this is the installed routes from VPN v4. Same thing here. This one. Okay. So we have 3 L3VPN services working. Now I'll send back to Ian to we will delete some of the services.
Thank you, Roberto. And I'll show you, I will delete one of the services, and you can then show that traffic is flowing on the remaining ones. So I'll take the middle service, or I created several services at the same time now last, but I'll delete the Polish network. Warsaw and Katowice. I'll show what deleting. So we are deleting those two. And if I do a commit dry run, I can show you what will happen on the devices. We know what to look for. So on IPI31, we'll delete the subinterface on E3, delete the VRF 2039. And on IPI32, it's again the subinterface 0 on E3 and 2039. That's going away. So show us the traffic on the two other ones, and that this one is gone.
The VRF 2039 should be gone. Yeah, it's not here anymore. The BGP VPN v4 prefixes. We have only two now, the remaining. Same thing here. Only two prefixes. And we should have only two routes. 2022. Same thing here. So we have two L3VPN services working. Now back to Ian. He will delete the remaining services.
Very good. So yes, I'll delete the last ones. I'll just do a simple L3VPN service. I'll show you what's going away. It's removing the Helsinki site, the Tampere site, the Berlin site, and the Frankfurt site, and some boilerplate stuff at the top. So I'll just commit that here. Should be done. Let's have a look.
Thanks, Ian. Now we should have no VRFs here. Yeah, everything is gone. And also we should have no routes installed from VRFs. Yeah. Right. Should have any IP address configured. Stage 2, stage 3, stage 4 have no IP addresses. So, okay, it's clean. Very good.
Very good. Let me show then that we have no residual configuration as well, as I promised in the beginning. So the way to do that is in NSO is to do device API 31 compare. And we see that there's exactly nothing remaining or nothing missing. So NSO is in perfect sync with the devices, and there's been nothing added, nothing removed compared to what it was before we started this exercise. Very good. So here we can see that we came through and we did show some NetConf network-wide transactions and show that we could set up and tear down VPN networks on the IPI OcNOS devices. And we were using standard models, as you could see if you looked carefully. And we had many service instances that we were adding and removing in any order. So with that, thank you for watching.
Thank you.